All right, so here's a problem where we're asked to find a few different things. I'm going to start out with the base area here, since identifying the base is one of the most important pieces. Now, the way you can identify the base, and you can kind of see that I already did down here, is that well, frankly, it's the only piece that, unless it's a rectangular base prism where everything can actually be a base, it's the only thing that's not a rectangle, or if it's oblique, a parallelogram. And so you can clearly see here, I got a rectangle here, here, oh, I got triangles here. And in fact, they gave me a right triangle, so it's even nicer. So what I went ahead and did was I drew out my right triangle in a way that will allow me to find the base and the height very easily. And since this is a 3 times 2, 4 times 2, 5 times 2, 3, 4, 5 triangle, I actually have all these pieces. Not that they're necessarily going to be important, but they will actually. So to find the base area, well, this is just a triangle. So I can do 1/2 base times height. Okay, which actually just works out to what? 24 kilometers squared, or square kilometers. Now, the next piece is to find the lateral area, and that's the area of all the faces, so all these rectangles I was talking about earlier. Well, to find those, all we have to do, there's a couple ways. One, you could actually just see that the base and height of this particular rectangle here is 6 and 4. Base and height of this one is 8 and 6. And actually, you know what? I will do it that way, actually, because I want to illustrate something. So if you look at this face right over here, we have 6 and 4. So that's going to be 4 kilometers. And you know what? In the interest of something here, I'm not going to show the kilometer part. So what we actually have is 4 times 6, right? And then for this base, right, or this one here, well, the height doesn't change. So we have 8 times 4. So we're going to add that, 8, and let me do 4 times 8 times 8. And then for the one in the back here, well, you can see I found my hypotenuse. This leg right here is actually just 10 kilometers. So I know that this back base, or this back face, I'm sorry, is 10 kilometers times 4 kilometers, or plus 4 times 10. Now the reason that I did it this way is what I'm going to do is kind of show you a trick, and I did this in class too. You can factor out the 4, and then you add up 6 plus 8 plus 10, right? So you factor out the 4 and you're left with 6 plus 8 plus 10. Well, this is just the base perimeter. And this here is the height. So actually, the shortcut, or the easiest way to find this, is just multiply the height, 4, times the base perimeter, which in this case I could have found just with my little base cutout here, which is, I'm tired, I can't add, 24. Okay? 24. And I should have used units all the way through here, but I thought it would be too cluttered. But then you get that this is 96 kilometers, or square kilometers, right? So now we've got our lateral area, we've got our base area, now we just need to find the total area. Well, the total area is just everything, right? So we're going to take the lateral area, 96 square kilometers, and then add, well, I've got one base down here and one base up here, so I actually need 2 times 24 square kilometers. Okay, so that's 96 square kilometers plus 48 square kilometers. Add those up, and let me see what that's, 104 plus another 40, so 144 square kilometers. And now we have the total surface area. Now, the last piece of the puzzle is to find the volume. Well, the volume, okay, is found, and if you want to look at the video that I posted for this section, I break it down a little bit more clearly. But what we basically need to do is the base area is the number of cubes that it would have if this was only 1 kilometer tall. So I'm going to take the base area, that's the number of cubes for one layer, and since the height is 4, I've got 4 sections. Right? 4 sections, each one of them has 24 kilometers. So I multiply that by the height, or in other words, I do 24 square kilometers times the height, which in this case is 4 kilometers. And kilometers squared times kilometers is going to give me kilometers cubed, which is what I want. And that's, again, actually, in this case, it works out to 96 cubic kilometers, which happens to be similar to the lateral area. That's just a coincidence for this particular problem.